So I welcome you all to the second session in DevOps. Today we are going to cover the topics called virtualization and network essentials. What we covered in the first class was all about DevOps concepts, and we haven't touched even um, anything on the practical sides, right? So today we are going to touch base on it. Very first things that we are going to learn is about why virtualization, how it is being set up, why people are jumping to the cloud-based infrastructure these days, and what are the benefits of it. How would it take care of scalability, high availability, and redundancy aspects of the infrastructure, and why do we need it? Okay. Then we would be differentiating between the two different kinds of hypervisors which are available in the market, type 1, type 2. Generally in cloud, you would be finding type 1. On our operating systems, you would be setting up type 2. What are the differences between them, and when we use them? That's what we're going to learn. Now, once we have all these concepts cleared, we would be setting up our machines on VirtualBox. So this would be the software that we would be requiring for today's class. So if you haven't got VirtualBox ready yet, so I suggest type in Google VirtualBox space download. It would take you to virtualbox.org open source website. Download the version which is supposed to be there for your operating system itself. Okay, so that should happen in the background till we cover the virtualization part, and I will show you how to set up the virtual machines to create a local infrastructure that we would be requiring for all of these classes henceforth. All right. The operating system that we would be going to use is going to be Ubuntu. If you're not able to download it right away, it's not a case reason to worry about. You can download it and install the stuff after the class as well. We would be needing it tomorrow onwards. All right, so let's jump straight away. But before that, do you have any queries or doubts regarding whatever we have covered so far in the first module? Okay, good to hear that.
Yes,
Let's start. So
can you send me the
virtualization.
recordings?
Sorry, I didn't hear you.
Can you send us the recordings?
Uh, okay, I guess I already did. In case you haven't received that, I would connect with Swati, who should forward that to you.
Okay, I think they didn't send me, and the email address in their records is incorrect. So I will send the email ID to you in this chat.
Okay, I wouldn't mind that. I would directly mail it to you.
Okay.
All right, so let's begin. Why virtualization in the first place? Let's take a small example, okay? So let's say I am a developer and I'm willing to create my website, okay, which I just did, and I would be installing that on some of my machines. So let's say I have a laptop, I've set it up, and on my laptop I would be using some softwares for that, right? So maybe I install MySQL for databases. I've got Apache for my web server, and I'm using in the background PHP to handle all my dynamic requests. Okay, very simple LAMP stack. It's on based on Linux. So it's called LAMP, Linux, Apache, MySQL, and PHP. Okay, so that's the LAMP stack. So very generic these days that people are using for creating their small websites and all this kind of stuff. So I've created my small website here, and I have installed these packages on one of my box, which is having configurations like this. It would be having some RAM. Uh, Maybe I'm running it on 4 GB of RAM, and I have got 4 core CPU. So instead of core, we say 4x. Okay, 1x means one thread, 4x means four threads. Now this 4 core CPU would be 1.3 gigahertz or so. Very generic configuration. It's not a configuration that we generally find in the clouds. It would be much higher than that. The physical boxes would be having RAM as much as 256 GBs on one single box, running at 32 core or 64 core different CPUs. And storage would be 1 TB or so, depends how you set up the storage. Very generic thing. Okay, so I have this, and there is one more requirement for space. So I'd be using 100 GB of HDD. Okay, a normal configuration that any person out there would be having on his or her laptop. So I have deployed it on here. I have received one static IP address from my ISP through which I am uh, serving my web content. So let's say that I'm able to serve my website happily. No problem so far. My traffic is 1x. Now another day, my mom says that, okay, I want to see your website. So the traffic happens to be 2x now. Okay, so just try to relate it with the x factor. So the x factor is maybe 1,000 users. I'm just taking a rough example just to make it a little more familiar. So it's 1x traffic, I'm able to serve it. If I get 2x traffic, okay, so 1x was on the day one. Next day I received 2x because my mom tried to access my website. So I've got two visitors now. And out of this configuration, earlier I was generally using almost 2 GB was my operating system. Operating system was taking 2 GB of RAM itself. So that's 2 GB of wasted RAM rather. And then my application would be taking some amount of RAM and it would be maybe 1 GB. Earlier case. Now when the traffic is 2x, operating system still operates at 2 GB, right? What about the application? Application starts with 2 GB again. It increases according to the number of users that we are serving, the number of threads that the Apache is spinning on in the background, and the number of PHP processes that are running would determine how much amount of RAM is being used on the heap side or actually being used by the dynamic requests. So it's 2 GB of RAM on the application, 2 GB of RAM on the operating system. I'm already scarcing out on my RAM capacity, which is 4 GB. Now I start to move this utilization to the virtual disk. So if you're from a Linux background, you must be knowing what swap space is, or from Windows background, you must know something called virtual memory. Okay, so what this means is when you have RAM of 4 GB and there is a process which is not able to fit itself in that RAM, you actually use the disk, the secondary storage, as your RAM extension. Okay, so it is not as fast as RAM, but it would give you illusion that your RAM is not 4 GB, it would be of 8 GB, including 4 GB of your swap space. But actually what happens when you try to write and read from the swap, it would be at the speed of your disk, which is very, very slow in compared to RAM, and that impacts the performance. So right now I'm happily serving my clients 2x. Next day, my sister comes in. She wants to spread a word about my website to her friends. Now she says that, okay, I want to access your website. Now the traffic is going to be 3x, but unfortunately, I'm not able to serve that traffic. She brings in more promise that she would be telling her friends as well. So I'm expecting a traffic to grow by almost 5x or 6x, 6x times. But here, I'm having capacity of 2x only. Now there's the problem. How do I scale up? Okay, so there are two scaling methodologies: scale vertically and scale horizontally. So let's say what scaling vertically means. Scaling vertically means to increase the capacity of the system. Here, my RAM capacity is 4 GB. I go out, I buy some RAM, I install it into it. Okay, so that would help me serving the traffic. Okay, so I bought 8 GB of RAM. So I increased my capacity to 4x. But my sister is promising about 6x or 7x kind of traffic. So how much should I increase? I need at least 14 GB of RAM for 7x traffic, and I wouldn't be running it at 100% utilization. I at least need some space for my own work, right? So better I go out and buy 16 GB of RAM. Okay, so I'm buying 16 GB of RAM, hoping that I would be getting 8x traffic. All right, so my sister was fine. She spreaded her word, and I started getting 8x of traffic. I'm happily serving 8x of traffic now. No problem so far. But now this CPU, which was actually running at maybe 40% of utilization, now started to consume almost 80% of CPU power. Okay, because the number of threads in the background increased. So that's fine. I'm still okay with my CPU, but it is causing some heating problems or um, some load problems, I'm not able to spin up any other application on my laptop. Okay, so I want to make better use of it. So what I decided is, last time RAM worked for me just pretty cool, so I'm deciding over buying a CPU this time. Okay, how does the cost increase when you try to scale vertically? RAM cost doesn't increase. The memory cost, whatever you are buying, doesn't increase in an exponential factor, but CPU cost does. If you're buying maybe 1 GB of RAM and that costs you X money, if you buy 2 GB, it would be costing you 2X, a fairly sane amount of increment. You buy 4 GB of RAM, would be costing you approximately 4X of money. Okay, what about CPU? Currently I'm holding 4X 1.3 GHz CPU, right? I'm trying to make it 8X octa-core, same 1.3 speed. It's not 2X anymore. It's almost 4X speed. Now, almost 4X of money that I would have to shell out for that. Even if I don't want to increase the cores, if I simply move from 1.3 gigahertz i3 processor to 1.3 gigahertz i9 processor, again, the cost factor is huge. I guess it's somewhere close to 7X or something, but I'm not sure about it. Okay, so it doesn't help us when we try to grow CPU power. It wouldn't help us in on the money factor. It's better to get a separate CPU for that. Okay, so instead of wasting 7X or 4X amount of money on just buying a CPU, you know that hard disk, sorry, your motherboards would be very inexpensive these days. So I would be spending more on that instead of getting a new brand new CPU. So what I decide is vertical scaling isn't working for me anymore. Okay, if I have maybe 16x of traffic, in that case, even if I bargain over CPU and I get a new fresh CPU, I wouldn't be able to install 32 GB of RAM on my machine. The reason is my motherboard doesn't support it, so the ports have got some limitation. Okay, and I'm not a kind of person who would be able to buy blade servers or razor servers directly, because I don't hold the racks for that. How would I manage it? How would I keep it? It would add another cost of cooling, power, maintenance, racks, and all this kind of stuff. I don't want to get that. So what I do is, instead of scaling up vertically, I would be concentrating on scaling horizontally. Okay, I know that at a fair amount of money, that means 16x of RAM and 4x of CPU power, the older configuration that I was serving, I'm able to serve 8x uh, amount of traffic. So what I do is, I already have a box that I'm happily able to serve 8x traffic. Okay, if the traffic increases, it doesn't make sense for me to shell out 7x amount of money just to increase the CPU power, right? So what I do is, I simply get another box. Now, the amount of traffic that I am able to serve is exactly double. Two of these boxes would be 8x and 8x each, would help me to serve 16x traffic. That's more economical. I don't need to configure anything. I don't need to change any hardware level systems or configurations, no software requirements, nothing. I just drop in another box and I should be able to serve this thing. Now there are problems when it comes to buying commodity hardware. Of course, commodity hardware is cheap. You don't need any special configuration or requirements for that. No provisioning. Okay, you could buy it at any local shop. It's okay. But the problem that starts here is that how do you ensure that all of these boxes are receiving the traffic? Because if there is one single LAN cable or a bandwidth wire, whatever the internet connection you are using, you would be plugging that in into one single box. How do you ensure that the traffic that is coming in goes to three different boxes? Okay, so I need a controller, right? So every architecture that you see out there in the cloud is reason of some or the other problems that other people have faced. So I need a controller here. Rather, I call it as a load balancer because it is balancing the traffic between these three instances that I've already started. Okay, so it should be moving the traffic to all these three things. And actually, my users would be connecting to load balancer because I don't want to spend a lot on buying different IP addresses. If I buy three IP addresses, I'll have to shell out 3x money, and I'll have to set up it on the DNS systems as well so that it gets load balanced. Instead of that, I just buy one IP address. Um, I get one single commodity hardware load balancer that should be able to distribute the traffic between these three instances. Okay, so this is how I scale up horizontally. But there is another problem here. When I move this concept uh, at a higher level, when I want to serve it, serve multiple people out of it, not at the application level, but at the infrastructure level. Because my friend also wants to set up his own website now, and he is not willing to shell out money for buying different hardware. I see that my resources are actually getting wasted because I'm not using 100% of it. I might be using 30%, 40% of my CPU power, my RAM utilization, and also on my disk. So if I want to share these resources with my friend who doesn't have money to buy all these four machines at once, what do I do? And the solution to this problem is actually the central dogma of all the cloud service providers. So what I would do is I would have these boxes, and on top of these boxes, I would install a kind of software that would help me in distributing the resources between the two applications. Now my friend says, okay, I don't trust it at the application level because might be your application is taking more amount of RAM and my application is not taking that much amount of RAM. How do we distribute it evenly? Because I'm paying half the money, you are paying half the money, I should be getting half the amount of resources that are there on the physical machine. I say, okay, what I'll do is I would be setting up a small layer of operating system on top of my machine. Okay, and I would call it as a hypervisor. Now, hypervisor is a kind of software that installs itself either directly on the hardware of your system, like BIOS. Your operating system lies directly on top of the hardware, right? So instead of operating system, if I install hypervisor, that would also work. And there is another kind of hypervisor that installs itself on top of your operating system. Okay, so these two different kinds of hypervisors are there in the market. Type 1, which installs itself directly on the hardware. Type 2, which installs itself on top of the operating system. Well, with here, I'm using the type 1 hypervisor for now. We'll get into details in the coming examples. So I say, okay, I would be using hypervisor and I would be creating compartments with my resources. So if I'm having 16 GB of RAM on my system, I would be distributing that into 8 GB, 8 GB. You do whatever you want to do with your 8 GB RAM, and I would be using that for my application. Make sense? So underlying operating system is removed. I have divided that into two separate chunks, and this machine here should be able to spin two operating systems now on top of it. Okay, so that's my operating system, and this is my friend's operating system. So my friend is now paying me only for the services that he's using. So he's not paying me for 16 GB RAM. He is paying me for 8 GB RAM. Okay. Moreover, the total cost of ownership for my friend has reduced. He has not bought any of these machines. I'm only charging him for the maintenance cost of it. So next day, if my friends want to switch from my service to someone else who is working on the same idea, he can simply take his machine, deploy it somewhere else. Okay, so best part about using hypervisor is that whenever you use your machines, there would be a file that is created in the background, and that file is called virtual image. Okay, more specifically, it is virtual disk image called as VDI. So whenever you want to move the machine out, I would be using VDI. Okay, I'll show you how the VDI is created in type 2 hypervisors. You could copy that file into your pen drive, take it to any other hosting service provider, and tell them that I want to spin this node on your machine. He would be happy to spin it for you. Okay, so that's how I would be providing services. And if I grow this to multiple machines, I would call that as a cloud. So let's jump to what cloud actually is. I hope you are you got a complete idea of what vertical scaling and horizontal scaling is, and how it relates to the cloud kind of services. Now we are going to explore what cloud really is. Okay, so this problem, when was taken to enterprise level, they say that okay, we have capacity of buying multiple machines at once. So what I'll do is I would be provisioning a few boxes. I would buy a bigger box. I would keep that in a rack. I would be specially working on providing these services to the people who are not willing to pay upfront, or who don't have capacity to buy that complete hardware at once, or who don't want to have overhead of managing all those things. They just want to concentrate on the business and software development part of it. So that's fine. So on data centers, I would be having a big box, preferably of 256 GB of RAM, some 64 core or 32 core CPU power, and all those kind of stuff in there. So what we say is, okay, I have a controller. So there would be a controller in a data center. Data center is a space, a physical space rather, where all your physical hardware or computers would be kept. Now at one single system, maybe a pool of systems, currently we are not talking of clusters, I'm talking of individual machines. There would be a controller. Now this controller is responsible for talking to any of the hypervisors that we are installing. So on top of the hardware, we have hypervisor. We don't have operating system directly. The reason we don't have a don't have an operating system here is that cost factor and performance factor. If you're purely into service business, you wouldn't be spending even a penny on the things that your users are not buying from you, correct? So if I happen to run operating system on top of my machine directly, I would be spending some amount of money on the resources, right? An operating system would be using almost 2 GB of it on the big servers. Moreover, operating system would be having its own process management, its own memory management kind of thing, which is going on in the background. So it has got its own processes which are running. So these processes would be using RAM, would be using CPU power. For these things, no one is going to pay you anything. Okay. At the same level, if you use the same resources for spinning up another virtual machine on top of the hypervisor, people would be happy to pay you for that. So what we do is, we don't have an operating system here on these machines. We have a layer of software which we called as hypervisor. So this is type 1 hypervisor, very specifically on the data center side. It would be your physical machine. Okay, now the controller is responsible to talk to this hypervisor. And once you set up this connection there, configuring this machine is a manual task. Okay, you have one machine, you install hypervisor, you put it in a rack, and you are done. Everything else would be controlled by the controller now. If you say that, okay, controller, I need to spin 3 different virtual machines, where do I spin it? So controller would itself figure out the empty resource for you. Controller knows that this machine, the physical machine, would be having some capacity. So maybe just for a rough example, I would be taking it. Maybe it has got 20 GB of RAM and 4x CPU power. In that case, if I want to run 2 virtual machines here, the controller would be spinning it up for me. And the controller would say that, okay, hypervisor, please group it into 2 GB of RAM and 1x computational power. If you take 1 GB RAM and 1x computational power, I would call it as EC2 instance in Amazon, the micro EC2 instance. Okay, so all these configurations have got some names. Bigger the group, the different the name would be, and more would you'd be charged on it. So there are micro instances, there are mega instances, there are T1 instances that are there with different providers, and you'd be using any one of these resources which is applicable to you, which suits your requirement. So if you want to spin up a machine which needs 4 GB of at least RAM, so you'd be saying that, okay, controller, please spin me a machine which is 4 GB in size, RAM size, and having 2x computational power. So the controller would again check if there is enough space available on this single machine. If it's not, it would look for another machine in there. Okay, and controller also has got a few more features. Let me talk of these features. Very first, it is uh, controlling VMs. Okay, then it is monitoring health of the physical hardware. Okay, then it is also load balancing. How does it load balance? It says that, okay, if I have two different physical boxes, both of them are 20 GB in capacity, and I want to spin two different virtual machines, I would not be putting both the virtual machines on one single system. I would rather distribute it as one virtual machines on both the physical boxes. Okay, so that's how it would be load balancing. So these controllers have got their own APIs or interfaces, and one such interface is provided for the user itself. So if I am willing to use the service, I would be somehow using a few features of the controller to spin up my machine. That's how I get a nice dashboard in AWS. And AWS would be charging us for amount of time and resources that we are spending here on its infrastructure. Now, where did this virtual machine actually started? The virtual machines started in an era of Solaris, where we used to call it as Solaris containers. Solaris containers allowed to spin multiple instances of the same software, or sorry, not software, the same operating system on the same machine. You must have heard about multi-boot facilities where we could have Windows and Linux or Ubuntu working on the same machine. But here, there's a difference. The difference is in multi-boot facility, you could actually have only one single operating system running at a time. You cannot run both of them. But in case of Solaris containers, you could actually have two operating system copies running. Both of them, of course, would be Solaris running on the same machine. Now, the ideas were quickly copied by Linux people, and they started to implement them, those ideas into its kernel. Okay, in Linux containers, which are called LXCs, they provide us with a facility of process level isolation, not at the operating system isolation. So these containers say that I would be using one single operating system at the base, but if you want to run multiple processes inside of it along with all its dependencies bundled up, we will talk of Linux containers in detail. The technology is called Docker in the coming classes. Just an overview now that these containers would be helping us to bundle up all these process level dependencies into one single package. So if I say I want to run Apache, okay, then take all your Apache files, configuration files, your installation packages, your code, or everything there in one single tarball and spin it up on any machine. So that's portable. I don't need to worry about what operating system it is, what is the machine configuration on it, whether it has got Apache installed or not, whether it has got any supporting packages installed or not. Nothing to worry about. That's what Docker is. Now it came to world of data centers where people actually wanted virtual machines or different copies of operating system to be executed at one single point with easy backup. So it started with virtual machines. Now these are actually the emulators. When we talk of virtualization, there are two different kinds of softwares: simulators, emulators. When you are actually replicating a real world scenario using a software, that's simulation. Virtual reality, that's simulation. But when you duplicate the existing resource, okay, so the resource already exists, I'm not creating a replica of it. I would be creating just a small subset of it, and that's emulator. Okay, so let's say I already have a CPU, but that CPU doesn't play well with Android devices. So what I would be doing is I would be creating a copy of CPU which is compatible with Android device. I'm not creating actually a smaller replica. Whereas in virtual reality, you create it's different. You create a replica of it. Okay, which is not that much efficient. In case of emulators, it is having the same efficiency and all the features of any of the thing that you are using. There would be some loss happening on the simulator part. With emulators, it does not. So when it comes to hardwares, we generally emulate them. When it is a human feelable kind of thing, or tangible or intangible assets, we use simulators for that. So virtual machines are actually emulators. They duplicate your hardware. Okay, so they would be providing you with a layer that acts exactly as your hardware would, but now this hardware has got some different capacities to provide. And using those capacities, your operating system would be running on top of it. So virtual machines would be providing me with a virtual hardware, and these virtual hardware, uh, on this virtual hardware, I would be installing my own operating system. So virtual machine is not responsible for running operating system directly. It's not pre-installed. You'll have to install it. Once you install it, there is one more feature of virtual machines, that it gets exported as files. So files could have multiple extensions based on which particular virtual machine provider you're using. VirtualBox would be creating VDI files. Then there is VMware that creates VMDK files. Then there is QEMU, which creates QEMU files. Okay, so everyone has got a different extension for that. But most virtual machines are compatible with some other extensions that are available in the market. So you could interchangeably use your virtual machine files. So what happens whenever you spin a virtual machine, it requires a file. Now that's a configuration file as well as the data storage file. So there is one single file that holds everything. Your hypervisor would read these files. It would decide that, okay, I need to spin this big machine. Now the details of that machine are stored in that file itself, along with any of the data that should be present on the disk. So let's consider one thing, that virtual machine is actually my hardware emulated. So if I'm talking of my laptop or any computer for that matter, uh, if you're not running operating system, what does it contain? It contains a hard disk, right? And on that hard disk, you have got all the configuration stored. You could actually take that hard disk, remove it, attach to some another computer, and you should be able to run that operating system just fine, provided there is no big change in the hardware configuration. So we are emulating the hard disk as well in the virtual machines. And this hard disk representation is actually the file that I'm talking of. So if you want to boot your operating system, all the data should be present on the hard disk. Similarly, all your hard disk details, along with the data, along with your operating system files, your configurations, softwares you install, everything is stored on one single file that the hypervisor should be able to read, understand, and provide you with the data. Okay, that's what the technology is. You need virtual machines, copy the file, replicate it simply as copy and paste, and virtual machines should take care of spinning two instances for you, along with the backup. Everything and anything that changes on the machine state, that means on the emulated hardware, your files should be having the updated records there. So if my virtual machine crashes for some reason, it goes wrong somewhere, my data is still safe in the files. Okay, so that file is always updated in the background, and that's the task of the hypervisor itself. Talking of type 1 and type 2, let's say type 1 hypervisor, and we have type 2 hypervisors. What are the differences and when do we use which one? In the data centers, type 1 is being used. Okay, examples would be Hyper-V, which is a Windows kind of hypervisors, so it supports Windows servers. KVM is used as type 1 hypervisor. Actually, KVM falls in both the categories, type 1 as well as type 2, because this KVM is actually kernel based virtual machine, where your kernel is injected with virtual machine capabilities. Actually, you simply install a package in there. This package is called overt, but this is another project that is running in the open source space. Now these people are providing capabilities to the kernel to use it as a hypervisor itself. So any of the hypervisors that you use, if it is Linux based hypervisor, would be having kernel in it. Okay, so KVM is an example of that. Another one is Zen, which is used extensively with AWS services. Also, Google supports using Zen in its own infrastructure. So that's type 1 kind of hypervisor again. Now in type 2, we use it for testing purposes. Testing in enterprise, or we test it on your own laptops. We call it as creating virtually environments on laptops. Okay, when we need very specialized environment, we use type 1. When we want to do some other kind of stuff as well, currently, let's say I'm conducting meetings, I'm doing something else, I need a calculator to be open, I need a Word document to be open. At the same time, I also want to test a virtual environment. So I need my operating system for say, right? And that's when we use type 2. Examples of it, VMware Workstation. Well, there is a product from VMware also as well in type 1, which is called VMware EXSI. Okay, so VMware EXSI is specially designed for the data centers, which will be having the controllers, the report generators, the log generators and maintainer systems. Then it also has got a services module that keeps track of who's using what and how much he or the particular person should be charged, right? So that's VMware EXSI or any of these systems. VMware Workstation is a type 2 hypervisor. We would be working with a free and open source version, which is called VirtualBox. Then there is another one which is provided by Windows. It's called Virtual PC. So I guess you must have used any one of these at least. If you haven't, doesn't matter much. So these are the differences actually. That these are the softwares that would be used in Type 1 and Type 2. Type 2 is operating system based. Type 1 is not. It is directly installed on hardwares. Now the performance drag that you get with Type 2 is more than you get in Type 1. Okay, you get performance drag in type 1 as well. Running an operating system directly on hardware and running an operating system on top of a hypervisor is different. Okay, so some of the resources, even if it is as less as 100 MB or so, it is used by the hypervisor for uh, its own purpose. Okay, so that would be the resource utilization which is there. Then your instructions have to be converted because hypervisor is an emulator. You think that it is the CPU, right? But it is actually not. See, it will have to run your processes on the actual physical CPU. And you are not the only one. You are not the only virtual machine which is being executed on the physical hardware. There might be multiple copies, and the hypervisor has to take care of it. So there is a performance drag. So your virtual machines are not same as the physical hardware. So while deciding on the virtual machines and designing the application layers, which we'll be looking at shortly, that how are application designed and kept in cloud, you need to take care of the physical impact, the performance impact of using a virtual machine in the data center versus using a physical box directly to run your systems on. Now the performance drag on type 2 is even more because the operating system is having all sort of processes running on itself, which would be taking up a lot of CPU and RAM power itself. Then on top of it, if you're running a virtual machine, then virtual machine have to wait, okay, for its turn to get executed there. And it is called time stealing. It's called CPU stealing actually. So even if you provide a CPU instruction inside virtual machine, that instruction would not be executed at the same time on the physical CPU. It would take some time for it to be getting scheduled on the physical CPU, getting it executed, and then reported back to the emulator CPU in the hypervisor. So that process takes time, and the lag that happens, it's called time stealing. Let's talk of application tier. What are the different application tiers and how do we set it up in virtual space? So I have virtual machines, all good. I can replicate them just by replicating the files and telling the controller that I need a different system. Okay, that's fine. But how do you take care of these problems? First problem is scalability. Now scalability could be vertical and horizontal. On cloud-based systems, you typically grow horizontally. The reason why? Because it makes sense to scale up whenever there is requirement and to scale down whenever there is a lean stack, sorry, not lean stack, lean time going on. In the peak times, you scale up. In lean times, you scale down. Because you know that the controller would be smart enough to charge you only for the resources that you are using, it makes sense to abandon the resources as soon as possible. Okay, so no vertical scaling unless and until it is really required. Vertical scaling on cloud means simply to use a different machine size. Instead of using 1 GB, 1x computation power, you could go with 2 GB, 1x, 2 GB, 2x kind of computation power. Okay, so scalability, how do we take care of that? Another one is high availability. Now, scalability doesn't account for high availability as well. So if I'm scaling up, how do I make sure that my machine never goes down? In the primitive example that we have seen, I had 3 machines, 4 machines. I was able to serve 16x traffic. Okay, everything good. But if you remember the machine configuration that I used, I configured MySQL, Apache, and PHP all on the same box. Let's say my database goes down for some reason. There's some problem, it got corrupted, it went down. As soon as it goes down, I lose the complete node. Okay, because Apache is not able to connect to MySQL, that node is gone. PHP doesn't work. Okay, or something happens to the operating system itself. So I would be losing all the 3 stacks, all the 3 layers. Now these 3 layers are load balancing layer is one which is communicating to that machine that is of no use if the machine doesn't exist. The traffic would not be coming down to the machine. That's one. Number two, my Apache doesn't work. Because the machine is killed, I'm losing my web server layer. Number three, I'm losing my database layer. If I could set them up in a specific order so that even if my Apache goes down, one instance goes down, I'm still not worried about it. Okay, that's when high availability concepts would be coming in. Another one, how do I maintain concurrency or consistency? What consistency means is if I say that, okay, I need some redundancy here, instead of using or high availability. So instead of using one single instance of my database, which is able to serve me 1x of traffic, I need 2x traffic. So I would be creating 2 different instances of databases. Okay, cool. You create 2 databases, but you need to make sure that the data that is being replicated between these 2 databases is actually doing that. So if I write to one database there, database A and B, let's say we have got 2 copies. I'm writing to A and I'm reading from B, or I'm writing to B and reading from A. Okay. So as soon as I write to A, it should move and get replicated to B. But in real world, that doesn't happen. That doesn't happen because A and B are physically 2 different machines connected somewhere with a network or a cable, and it takes time for the signal to move from A to B and register the change there on B. Data has to be copied from A to B again. On B, it registers, it executes the query, replicates itself, and bring itself to a state in which A is. Now, all these things require time because it's all CPU based, right? So it might take a very good of 20 milliseconds or so. Now, this latency time would impact. Now, this is a problem of consistency. Let's say I'm writing to A, at the same time, someone is reading from B. So the data that he would be getting would be the older data because the change has not replicated to B yet. Okay, so how do you account for consistency in the virtual environment? So there are solutions to that. One of the solution is redundancy. To handle it on the redundancy part, I need scalability. Okay, create redundant machines, create copies of machines. I need high availability. So alright, set up the machines like this. So I would be having a load balancer, and below the load balancers would be spinning up some machines. So let's see, instead of drawing, I would simply write the names. So we have got load balancer. So what is the use of load balancer? To spread out the traffic, right? And then I have got web servers. So I could say I have redundant web servers this time. I'm not running them on one single machine. So I've got web server 1, web server 2, web server 3, and so on. So in production, we never have multiple services running on multiple machines. And the reason for that is very clear, that if one service goes down or that machine gets corrupted or killed, anything would happen to that. I should not be losing all the stack. I should be losing only one single layer that belongs to the particular machine. So here in my case, I have got four machines drawn on the screen currently. Load balancer, web server 1 is one single box virtual machine that would be hosting only one service. That service is Apache. Done, nothing else. Now we have got databases. So I would say database 1 and database 2. Okay, so we have got databases. So what happens actually? This is a very basic kind of setup that the enterprises would be using. In bigger enterprises, you would be having multiple load balancers talking to one another as well as to the web servers. The web servers could be in multiples of thousands. Okay, so there could be a cluster which is as big as 1,000 or 5,000 different nodes. Okay, databases should be having fair number which would be supporting all the traffic from the web servers. Now the traffic moves like this: load balancer to web server, from web server to database. Now generally what we do is we don't keep the databases like this. Okay, so this configuration doesn't work because the databases would be required to replicate the data like this, and we don't trust the databases on their consistency values. Okay, so what we do is we generally come up with a solution that, okay, I don't need to worry about the replication factor. I would be using the inbuilt system which is provided by the virtual machine providers or the cloud providers. So what these cloud providers say that we would be providing you with a service which is scalable enough, and we would take care of the redundancy for you and also the scalability part on the database side. The services which are provided by AWS specifically is called EBS. Another one is RDS. That would be helping you with database redundancy problems. But if you want to set it up yourself, there would be another load balancer. Okay, and this load balancer would be acting as an entry to your database layer. Now, in ideal cases, you never have one single load balancer. You'd be having at least two load balancers so that if one goes down, second one should be able to take over. And beneath this load balancer, you'd be having your databases. Now, the algorithm of replication on the databases decides what kind of consistency you're looking for. There are two types of consistencies now. The consistencies, the first type says that you need a highly consistent system. Another one is eventually consistent. Okay, so there are two systems: highly consistent and eventually consistent. What does highly consistent say? If my system is supposed to be highly consistent, then if I write something to database 1 should quickly replicate that to database 2, and unless and until it gets replicated on database 2, it will not give a positive response back. Okay, so if I fire a query on database 1 would wait for database 2 to replicate all the data, get the confirmation from database 2, and only in that case it would mark the query as complete, just like firing a transaction. Okay, that's highly consistent system. But there's a drawback to it. The drawback is that the latency time, the network latency time also gets added to your query execution time. So the performance is a bit slow, but it takes care of this replication fine, and you should be able to use this configuration in the applications which are critical on the consistency. Example, financial applications. So all of your databases should be running at the same state, having the same values of whatever the amount is, right? Another one is eventually consistent. So in eventually consistent, the databases like big data, Google file system, GFS, or Lustre file system, cluster store products from Seagate, all these things are eventually consistent. Few of more examples would be Cassandra. That's a good example of eventually consistent database. So what it does is, whenever you write to database one, it says, okay, your query is registered. I will replicate it to database two. You don't have to worry about that. Okay, so you get okay response and you are okay with that. So when do you use this? And the replication happens on basis of timestamps. So database 2 detects that, all right, database 1 has got some new data in there and the timestamp is newer than what I am holding. So update myself with database 1's records. Similarly with database 1, it checks with database 2 as well. Okay, next time if the query goes and registers itself at database 2, one should be able to pick up those changes. But these kind of applications are only useful in case of social media or social networks, something like comment mechanism. If my friend comments on my post, it's not a time critical thing. I'm okay if I would get a comment 1 second or 2 seconds later. I don't need it right away, right? So these kind of systems which are requiring the traffic to be more on the read side and less on the write side are considered to be eventually consistent, and we use a big data store for that. Okay, so that's about a small overview on what cloud and the infrastructure things are going to be. Let's see how to implement that on our own systems. So by end of this project, we would be spinning up all these nodes. Yesterday we talked of three different, not yesterday, in the previous class, we talked of three different sections of DevOps, like CI, CD, and the CD part. We'd be setting up the complete build and release pipeline by end of this project. But for that, we need machines, right? So I would be spinning up a few machines here. I'll show you how to configure your very first box on Linux virtual machine. We would be using Ubuntu for that. And what are the different settings that we would be requiring for creating internal clusters. Okay, so very first thing, I need to get a browser so that I could show you where to download the things from. Okay, so download virtual box. It is virtualbox.org website. Get the link, click on it. It should take you to a page which would ask you to download for your specific operating system flavor. So if you are using Mac, go for that. If you are using Windows, download the virtualbox.exe file. Linux would be having its own flavor of VirtualBox. So let this page open up. All right. So it has got support for Solaris, Linux, for Mac, and Windows. So if you're on Windows, click this link here. I've downloaded it from the Windows link, and the exe file that you have, double click it, install it. So installation steps would be the same as you install any other software on your specific operating system. Okay, so here I have got a virtual machine already installed, sorry, VirtualBox already installed. Now I'm going to show you how it looks like. It looks like this, okay, but the difference would be you will not be having any machines on the left. Currently I've got multiple machines here, okay, which I'm using for some specific purposes. I'll show you how to create your own machines. For now, Nigest clients off the list, I don't need that. I don't need workstation. Okay, let's get cleared of it. So for creating a fresh virtual machine, what you'd be doing is click on new, okay, and you would be writing a virtual machine name. Remember that whenever we want a separate virtual machine to be running, we would be copying the file. Okay, the reason why we do that is if you have a machine A and you want to play with that machine, you want to install something on it, test it. So if I install directly on top of A and something goes wrong, I will have to reconfigure machine A. Okay, and I don't want to waste my time in reconfiguring the machine. So what I would be doing is I would be copying machine A to some another location and spin that machine again. So I would be having two machines now, A and B. I would play with B. If something goes wrong on B, I don't care. I would simply delete that, copy again from A, again create B, which would exactly be same as A, again mess up with that, again delete it, again copy it from A. So very first create a base machine. That base machine is called template. Okay, it is same as in case of cloud. In cloud as well, you would be creating templates. From templates, you'd be spinning up as many machines as you want. The reason why we use it, we don't want to waste our time in configuring packages and installing operating systems. You know that it takes time, installing an operating system, any operating system it might be. So here in this case, uh, I would be creating a machine. I would call it as dummy box. I have got already created one. I named it Ubuntu 14.04 that you're looking at on the screen, the top left. Okay. Now I'm creating the one called dummy. So in your case, you would be giving it some sane name, whatever makes sense to you. We would be not using Windows, we would be using Linux. On Linux, I'm using 32-bit Ubuntu machine, not 64, 32. The reason why I'm not using 64 is I understand that you would be using your own laptops or desktops for spinning up these machines, and we want to keep the resource utilization to minimum. 64-bit instances would take twice as amount of RAM as in on 32-bit instances. So if my 32-bit instances would be running in 1 GB RAM, same performance I would be getting in 64-bit machines if I provide them with 2 GB of RAM. So the resource utilization is more. So that's why I keep it to minimum. Spin up at Ubuntu 32-bit. Next, provide the amount of RAM that you want this machine to be using. In our examples, unless and until I tell you, it is going to be 512 MB only. Okay. In most of the cases you should be able to spin up your Linux operating systems in as less as 400 MB or so. But remember that the operating system that we are using is Ubuntu 14.04 LTS server version, not the graphical version, not the desktop version. Okay. So I'll show you how to download that as well. So here it is going to be 512 MB. Next, it would ask us to create a hard disk. Of course, it's going to create a file. Okay, so let me quickly go to the location where it is going to create the file. So this is here on my box. This folder is where I'm storing all my virtual machines. How do you tell where it is? You go in file preferences. I'll show you the path. By default, it is going to be your documents. If you're on Windows, it would create the virtual machine folder in your documents folder by default. Here I'm going to create a hard disk. Now there are three options present. Very first, do not add hard disk at all. So if you just want to emulate the hardware without hard disk, that's an option for you. Another one, create virtual hard disk now, which is going to be a fresh hard disk copy or a fresh file, nothing installed on top of it. Another one is use existing hard disk copy that you already have. So if you already have a virtual machine and you want to run that virtual machine on your friend's machine, okay, on your friend's laptop, in that case you'd be taking that hard disk file and asking your friend to load it like this. Okay, so if this is the case, you see there is the extension called vmdk which is present. I would go with creating a fresh virtual hard disk copy because we want to install operating system on top of it. Click on create. It would ask you for hard disk type. I told you already that there would be different types of hard disk extensions. We would be using the one which is native to VirtualBox. It's called VDI, okay, or VirtualBox disk image. Click next. Again, how do you want to write data to this particular hard disk that you have created? Whether you want to allocate the disk already, that means if you want to create a hard disk of 8 GB, should the file size already be of 8 GB and it should be consuming all the space from the host machine itself, or you want to keep the file incrementing according to the use that you are doing inside. So if I'm copying some 10 MB of files inside my hard disk, then my hard disk size would be 10 MB. If I copy 1 GB of data, my hard disk size would be 1 GB. But there would be a maximum capping of it. Okay, so I don't want to block all the space on my host operating systems already, so I would be using dynamically allocated. So we would be using the same configuration for all the machines, any of the machine that we would be using. Next, provide a name for that hard disk file. Preferably, the name of your machine should be same as the name of your hard disk. So no changes here. The hard disk size that I need is 20 GB. Okay, but initially, since it is dynamically allocated, it would not create a file more than 2 MB in size. So don't worry about that. 20 GB is only a maximum capping. You cannot go beyond 20 GB. That's what it means. Create, and this is the virtual machine which is created. Let me move it off. Okay, so this is the virtual machine which is created. Currently, it is powered off. If you check the settings part, which would show you the different hardware setup that we have done already. General would tell you the machine name. Okay, advanced would provide you with the interaction that you would be doing with these machines. We'll talk of this in the coming sessions. Whenever we require a feature, we would cover that. Okay, so I will not be overloading you with all the information on these setup right away. When we need it, we would be covering that. System would be having your boot uh, order. So currently the boot order is floppy. No one uses that, so you could check it off. Optical disk, which is a virtual disk drive, so we would be requiring that to install the operating system. Hard disk, we need it. Network, we'll talk of network when we set up PXE environment. For now, we won't. Processor is again one core processor that you can spin. We don't need more cores. And execution cap, use 100% of it. If you want to enable acceleration of hardware, which is better for the virtual machines, if you have this possibility, if your system supports it, always keep it checked on. Okay, rest other stuff is just routine. We would need to set up something on the network part, but not now. I'll talk of it when we install the DNS, just a few minutes later. Okay, so nothing has to be changed here. And how to install an operating system now? We have simply created a machine. I emulated hardware. I want to install Ubuntu on top of it. So get to your browser again, write download Ubuntu 14.04. The link should be ubuntu.com/download. Here it would provide you with an option of downloading different flavors. Okay, since we are DevOps people, we are not a big fan of graphics on the operating system side. We generally believe in dashboards on browsers. So I'll be keeping the clutter very less, and we want to save a lot of resources on our laptops itself. So don't go with desktop version. It would install almost 700 800 MBs of packages, plus require extra 500 MB of RAM on your CPU, on your laptop. So I would be using the one which says Ubuntu server. Okay, so I would be clicking on that. It would give me an option of downloading two flavors, which is 15 and 14. Go with 14.04, which is used a lot in enterprise these days. 15 hasn't got a LTS with it, long-term service agreements are not present. So people use 14.04 and I'm going to use the same thing. Okay. Now there are alternative downloads which are present. Currently this release that you are seeing here is 64-bit. Okay, we need 32-bit, right? Alternative downloads and torrents, click on it. Here on this list, it would give you an option of downloading Ubuntu 14.04 LTS 32-bit. Do not go for desktop again. So the last link here is the one that we would be requiring to download. Click on it. It would be downloading an ISO file on your machine. It would be almost 650 or 700 MBs. Okay, so download that. Once you download it, you would be using that ISO image to install our operating system inside VirtualBox. Okay, so let's see how to do that. Open the settings part of your machine. Go to system, not system, storage. On storage, you should be able to see two controllers. One is the IDE, or which would be connecting to your virtual CD drive. Okay, and another one, which is SATA controller, would be connecting to your hard disk. So this time I need the CD-ROM, and here it says optical drive has got no disk. Let's add the disk there. So this button here on the right hand side, I am clicking on it. It says choose virtual optical disk file. Choose the one that you have downloaded. Okay, so navigate to the path where you have downloaded that file and load it here. So in my case, it is on my E drive, and this is the one that I'm using. Ubuntu 14.10 server i386.iso, or maybe 14.04. I'm using 14.04.2 server i386.iso. AMD 64, if you download AMD 64, it is going to be 64-bit. If you download 32-bit, it is going to be i386. Okay, so load this. It should say the name of the disk file that you have just loaded. Okay, make sure that on the system tab you have got optical drive on top of hard disk, otherwise it will not be on priority. Okay, so boot priority always should be given to the optical drive, and hard disk should be following next. That's all you need to do. Click on OK. Start the machine. To start the machine, either you click on the start box here, select the machine and then click on start button, or right click the button, or right click the machine and click on start, normal start. When you start it, it looks something like this, and there's your nice installation screen. Go through the installation steps. I don't want any fancy stuff to be installed. You would be following the guided installation. Nothing manual has to be done. And on the template, you would be setting up a few packages. I'm just hitting enter, the default configuration, whatever are there. I don't want to do any manual configurations now. It would take some time. We will not be going through all these installation steps. Okay, I just need the operating system installed. After the operating system is installed, any of the features that you want all these machines that you're going to create later on to be having. If you want a feature to be present on all the machines, better have that feature installed on the template itself. That means on the base machine that we are installing right now. So what I need here, we need to have two different NIC cards, okay, or network interface cards rather, uh, virtual of course. So these NIC cards are the cards in which you insert your Ethernet uh, cable. Okay, so the cards that provide you with Ethernet port are called NICs. So we need two of these NICs set up. By default, it is going to be just one NIC. So I'm going with the default screens, whatever it is asking, I'm providing these answers, and most probably I'm giving the default answers which are there. Okay, so I was talking of NICs. We need two NICs. The reason why we need two, okay, this is the important part. Partitioning disk. Choose the default one which is present. Use entire disk and set up LVM. When it asks to write the changes, click on yes. Go with the default again. No fancy stuff. Whenever it asks to write the changes to the disk, mark yes. Okay, so why do we need two NIC cards? The reason we need two NIC cards is we want to connect these machines together internally, right? For internal communication, we need one NIC card. And at the same time, since we are experimenting with these boxes, I would be requiring my host machine to able to be communicating to that. Okay, so I want my host machine to communicate with the virtual machines. That's the reason I need another NIC card. One NIC card can talk to only one network. It cannot talk to two networks at a time. Okay, that's the reason why we need two NIC cards, one for the external network, which would allow my host machine to talk to these boxes, another one internals. Uh, but the configuration that we would be using is going to be a bit different. I would use NIC cards for a separate use. One NIC card would be helping me to connect to the internet, whereas the another NIC card would be helping me to connect to the host box. So the first example that I have given you, it is about the data center part. Here in the local environment, it is going to be a bit different. We want internet connection to be available on all these machines. Generally in production, you have internet connection only on one box, which would be treated as a gateway. You set up everything there, and all the machines would be connecting to that one single machine. Here the things are a bit different. So should I wait for this to finish? So let's wait for it. It would eventually finish in a few minutes. One more difference between server edition and the desktop edition is that on desktop edition you have got auto upgradation on. So it would try to fetch all these fancy kinds of packages and updates and security patches and all those kind of things and implement that as soon as you install the desktop version. Okay, so the time that you need to set up desktop version and to upgrade it is more. On server versions, only the security patches are available. Any of the upgrades are disabled by default. So that happens to be really fine and really faster kind of installation that you do. I would wait here for another few minutes. If that finishes off, you would be using the same machine for setting up the other packages. During the installation steps, it has also asked me for providing the username and the password as the admin username and password. So I've given that as well. Remember that you would be requiring it or you would be needing it multiple times. Sorry. So by the time that happens, feel free to unmute yourselves, type in anything in the chat boxes. If you want to ask any questions, have any doubts, need more clarification on the subject, feel free to communicate. Okay, I don't want this to be a one-way communication. It would require some more time. It's not done, it's almost 39% just. There will be some more files which are supposed to be downloaded. Okay, so I guess it is going to take a lot of time. What I'll do is I will quickly show you how to set up the packages and what we are going to do on the configuration side. By the time if it finishes off, we will be doing it again on this box. Okay, so that's almost done. Since this is a server version, it would not be installing any of the graphic software. It will not be installing any of the fancy editors. Okay, so currently it's asking me for the default. So I would say no automatic updates, the default one. Which softwares do you want to install? Now this is the important one. I would be required to choose OpenSSH server, which is on the top list. If you don't choose it here, you'll have to set it up manually. Okay, so how do you choose it? You can move up and down using your arrow keys, and the one that you want to select, place a space bar. If you hit space, it would place a star on that particular option, and that's how you select that option. In my case, I'm setting up OpenSSH server. Okay, and hit enter. Do not install any of the other services. Okay, OpenSSH service is the only service that we need on all the machines to be installed. The reason why we do that, we want to communicate to these machines remotely and also want to set up interaction between the two boxes. That is the reason why we need OpenSSH server. We would be using SSH protocol that operates on port number 22 to communicate between these boxes. It is by default very secure. It can also communicate over using keys instead of passwords, has got very good deal of security setup. So I need OpenSSH server. None of the others are required. I'm waiting for this to finish. I hope that finishes off in a few more minutes, I guess. And then we would be setting up the network. Okay. So that's almost done. It should automatically restart. If it asks you to install grub bootloader to the master boot record, go with the default ones. So it is a complete guided install. We haven't done anything fancy. It tells us that installation is now complete. So you are free to remove the disk from the CD-ROM. Start with doing the same. Actually, it removes itself, so you don't need to worry about that. And we have successfully installed Linux. It will bring up a boot screen, automatically boot itself, come to a prompt, and it would ask you for the username and password. By default, there is going to be a NAT adapter already present, so you are already connected to the internet. I've typed in my username and password. If you try to ping Google, that should work. If it's not working, that means there's some problem. Okay, you should be able to connect to Google and hit ping Google and get some response back. Okay, I was talking of the packages. OpenSSH we have already marked there. Just in case you fail to install OpenSSH, you would be installing it like this. Type in sudo apt get install OpenSSH hyphen server. That's the package name that I'm installing. Apt-get is actually um, a software manager for Ubuntu systems or Debian systems rather. So sudo apt-get install OpenSSH server should be asking you for a password. Type in the password. It would install OpenSSH on this machine. Whenever it asks, do you want to continue? Click on Y. Just type in capital Y and hit enter. Small y works as well. How to check whether OpenSSH server is working? You could do something like this: sudo service SSH status. Service SSH status should tell you that SSH service is already started and it's running on particular PID. That's it. So that's the stuff that you want to configure inside the operating system, nothing else. Okay, so you have successfully created your base machine. Another stuff that you would be doing is setting up the network interfaces and setting up the ETH adapters here inside the operating system, but that would be in the next session. So in the next session, what we're going to cover is, let me bring up that app again. In next session, we would be talking about networking essentials. Actually, it was supposed to be covered today, but let's not speed up the things. I'll take it very slow. At any point, if you think that I'm speeding up, just let me know. In network essentials, we would be covering up DNS, we would be covering up DHCP servers, how to configure them, how to create nodes, how to make the nodes talk to one another and grant them IP addresses, static as well as dynamic. We will also see how to propagate the information using DHCP into the network. Okay, all the machines need to know where the gateway is, which is the domain name that they should be using, what should be their IP addresses. Okay, um, where they should be searching for any DNS records if they want to. In that case, DHCP is the server that would help us in propagating those data or details inside the network. We would also learn about IP addresses, their classes, and subnets. Okay, so this is going to be covered in the next class. So that's all for today from my side. If you have any queries or doubts, feel free to ask. You'll be getting the recording in at least 1 or 1.5 hour. Um, but if you get it directly from me, if you get it via Swati, it's her lookout how fast she would be mailing it. From my end, I would be sending it in 1.5 hour or so. Any questions or doubts that you want to ask?
Can you send directly?
I'm sorry, I'm not able to hear you clearly.
So, can you send directly for us?
Yes, I would mail it directly to you. For the people whose email address is not with me, I would get it
Okay.
routed via Swati.
Okay. My email address is in chat box. Can you check it?
Yes, I got it.
Okay. Thank you.
Any other queries or doubts? Anyone?
Uh,
Mhm.
no, sir.
Okay, so I've got email addresses of all of you. I'll be mailing you directly. Okay, and you should receive the recordings as well as the details on the practicals, how to do the practicals, some documentation on the course curriculum, and all those supporting docs in a shared Google Drive so that you could connect to that and download it from there. Okay. Just for your reference, I would also share the existing videos, which I already have from the previous classes, so that you could go through the next video that we are going to cover, okay, and get yourself familiar with the terms. So that should help you out, okay.
Okay.
Any more things that you want to ask or share? All right, people. So I would take your leave for today. It's 1.5 year class that we have finished. Tomorrow, I guess. Okay, tomorrow I have some another stuff going on. So we'll be continuing from Wednesday onwards on a regular basis. I would make sure that we do not skip any more classes, and we should be able to finish this course in matter of 4 or 5 more weeks which are coming in. Okay, I would share all the recordings that we have got until now. Okay, so have a great day ahead, and I would see you on next day, which is day after tomorrow. It's Wednesday. Have a great day ahead. Thank you for joining the session.
Thank you.
Okay, thank you.